So in this video, we're going to be working on finding the graphs of exponential functions. So let's first start with sketching the graph of the function y equals 4 to the x. So if we put in -2, we have that y would be 4 to the -2, which would be 1/16. Remember, that's 1 over 4 squared. If I put in -1, I get 4 to the -1, which would be a fourth. If I put in 0, I get 4 to the 0, which is 1. 4 to the 1 is 4. 4 to the 2 is 16. And 4 to the 3 is 64. So if we look at our graph, then when we plot our points, let's look at our y's. We go from 1/16 all the way up to 64. So let's count off by, let's say, 5s. So that would be 10, 20, 30, 40, 50, and then up in here would be 60. So let's start plotting points. So when x is -2, we had 1/16, which is going to be right here, barely above the y-axis. Then we have a fourth, which is a little higher. When x is 0, we're at 1. When x is 1, we were at 4, so that's going to be a little below 5 there. When x was 2, we were at 16. And then when x was 3, we were way up here at, say, 64. So if I start plotting the points and connecting the dots, you'll see my graph is going to do something like that. And remember that that line that we're going to approach but not cross is an asymptote. So as our x's go towards -infinity, -2, -3, my graph gets closer and closer to the x-axis, but it doesn't touch the x-axis. Let's look at another function. Let's look at the graph of 2 to the x. So if I put in 2 to the -2, we get a fourth. 2 to the -1 is a half. 2 to the 0 is 1. 2 to the 1 is 2. 2 squared is 4. 2 cubed would be 8. So again, plotting those points, -2 would put me at a fourth. We're going to count our, this time we'll count our y-axis off by 1s. So 2 to the -2 would be a fourth. 2 to the -1 would be a half. 2 to the 0 would be 1. 2 to the 1 would be 2. 2 to the 2 would be 4. And then 2 to the 3rd would be 8. So again, connecting our dots, we'll see our graph looks like that. Notice that compared to 4 to the x, the graph was not near as steep when I graphed 2 to the x. So if I looked at the graph of 4 to the x, I would expect it to look something like that, where this would be 2 to the x. So my graph is steeper the larger the base is, then I'm going to expect my graph to grow quicker, and so my graph would end up being steeper. Now, one last thing we wanted to do with these graphs is look at transformations like we've previously done. Remember that when you have numbers inside of the parentheses, they're going to move you to the left or right. Numbers on the outside move you up and down. So if I look at the graph of 3 to the x plus 4, remember that would be the same thing as this. So I'm translating this thing left and right. Since it's a plus 4, we're actually moving to the right, or to the left, 4 places. So normally, if we go back to our previous two graphs and look at those, you'll see that both of those points went through, or both of those graphs went through the point 0, 1. So exponentials are going to normally flow through the point 0, 1, but since this graph has been translated 4 to the left, I'm going to move that dot over, and now what's going to happen is my graph is going to start flat and get steep, And I want to make sure that I have the point negative 4, 1 as my point that I'm going to make sure that I pass through. Notice that I also have the asymptote still at the y-axis, or the x-axis. Now the next graph, we have a minus 3 at the end, which is going to be a translation down 3 places. So again, normally my graph would go through the point 0, 1, but we're going to translate down 3 places, which is going to put me down here at negative 2. Since this is a 5 to the graph, I expect it to be very steep. And I still have an asymptote. And since my point is down at negative 2, my asymptote would be right here at negative 3. So make sure you keep that graph so that it doesn't go past negative 3. And then the last thing is e to the x minus 2 plus 1. Remember that we said e is approximately 2.7. So this is similar to the graph of 2 to the x and 3 to the x. The minus 2 in the top is going to be a translation of 2 to the right. The plus 1 is going to go up 1. So my point would have normally gone through 0, 1, but now I'm going to the right 2 and up 1. So that puts that 1 point at 2, 2. So it's an E, so that's 2 to the, so I don't expect it to be real steep, or 3 to the. And now since my point is at 2, 2, my asymptote has to be at 1, so I would not expect that graph to go down past 1.